Here we have divide and conquer. This is a little change of pace from the data structures that we've been focused on. It's an example of an algorithm approach. These algorithm approaches tend to be a little more rule of thumb and not quite as clean cut as far as I'm concerned as the data structures, but they are useful for some things. So here's divide and conquer. The basic idea is we take a large problem, we break it into a series of similar but smaller problems. We solve each of these small problems, and then we combine the solution to all the small problems to give a solution to the original problem. Classic example is the merge sort. We start with an array to be sorted. We divide it into two smaller arrays. We divide each of the smaller arrays over and over until we have an array with only one item. With only one item in the array, by default, it is now sorted. It's kind of a trivial sort, but it's sorted. And so we've solved each of the subproblems, and so then we merge each of the sorted arrays back up until we get an array with all of the starting numbers now sorted. A similar example is the quick sort. In the quick sort, we partition an array of numbers over and over. As we do, the partition element moves to its final position and the two partitions grow smaller until either they become a one item, in which case they're sorted, or we get them small enough that we just apply an if statement, or possibly even a simpler sort to finish sorting that. Then they're in order. So the overall approach is we divide a problem into two or more pieces and we make a recursive call for each piece. We repeat that until all of our subproblems are solved, and then we combine the results to get a solution to the original problem. Some other common examples that use divide and conquer: traversing a binary search tree, finding the height of a binary tree, something called the closest points problems, a graphics problem, fast Fourier transform, which is used in signal processing. It's similar to, but different from, and often mistaken for, something that should properly be called decrease and conquer. In decrease and conquer, we divide a problem, but then we remove one part from further consideration, making the problem smaller, hence the term decrease. An example is a binary search on a sorted array. We divide the array into two parts when we decide which half to look in, but once we start looking in one half of the array, we never consider the other half again. So the problem becomes smaller, but we don't have to recombine the results. A distinction: if we have two or more recursive calls, we have an example of divide and conquer. If we have only one recursive call, we have an example of decrease and conquer.